Welcome to the chapter on Physics Basics. Understanding the fundamentals of physics is crucial for any electronics engineering student. In this chapter, we will cover electromagnetism, quantum mechanics, and solid-state physics. Electromagnetism is the study of the electromagnetic force, a type of physical interaction that occurs between electrically charged particles. It is one of the four fundamental forces of nature and is described by Maxwell's equations. An electric field is a region around a charged particle where a force would be exerted on other charged particles. The electric field E due to a point charge q at a distance r is given by the formula E equals q divided by 4 pi epsilon naught r squared, where epsilon naught is the permittivity of free space. A magnetic field is a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetic materials. The magnetic field B around a long, straight current-carrying wire is given by the formula B equals mu naught I divided by 2 pi r, where mu naught is the permeability of free space, I is the current, and r is the distance from the wire. Faraday's law states that a change in magnetic flux through a circuit induces an electromotive force, or EMF, in the circuit. Mathematically, it is expressed as E equals negative d phi sub b over dt, where E is the induced EMF and phi sub b is the magnetic flux. Transformers use electromagnetic induction to convert voltages from one level to another. They consist of two coils of wire, the primary and secondary, wound around a magnetic core. When an alternating current flows through the primary coil, it creates a changing magnetic field that induces a voltage in the secondary coil. Quantum mechanics is the branch of physics that deals with the behavior of particles on a very small scale, such as electrons and photons. It introduces the concept of quantization of energy levels and wave-particle duality. Particles such as electrons exhibit both wave-like and particle-like properties. The wavelength lambda of a particle is given by the de Broglie relation, lambda equals h divided by p, where h is Planck's constant and p is the momentum of the particle. The Schrodinger equation describes how the quantum state of a physical system changes over time. For a particle in a potential v of x, the time-independent Schrodinger equation is given by negative h bar squared over 2m times the second derivative of psi with respect to x, plus v of x times psi equals e psi, where h bar is the reduced Planck's constant, m is the mass of the particle, psi is the wave function, and E is the energy of the system. Quantum tunneling is a phenomenon where particles pass through a potential barrier that they classically shouldn't be able to. This is a key principle in the operation of semiconductor devices such as tunnel diodes and flash memory. Solid-state physics is the study of rigid matter, or solids, through methods such as quantum mechanics, crystallography, and electromagnetism. It forms the theoretical foundation for materials science and semiconductor technology. Solids are often composed of atoms arranged in a repeating pattern called a crystal lattice. The simplest lattice structure is the cubic lattice, which includes simple cubic, body-centered cubic, or BCC, and face-centered cubic, or FCC arrangements. Band theory explains the behavior of electrons in solids. According to this theory, the energy levels of electrons in a solid form bands. The valence band is the highest range of electron energies in which electrons are normally present at absolute zero temperature, while the conduction band is the range of electron energies higher than the valence band. Semiconductors are materials with electrical conductivity between that of a conductor and an insulator. Their conductivity can be modified by doping, which involves adding impurities to the material. The two main types of semiconductors are N-type or negative and P-type or positive. Transistors are semiconductor devices used to amplify or switch electronic signals. They are the building blocks of modern electronic devices. A common type of transistor is the bipolar junction transistor, or BJT, which has 3 layers of semiconductor material and can be used in amplification and switching applications. By understanding these fundamental concepts in physics, you will be better equipped to grasp the principles of electronics engineering and apply them in practical scenarios. Thank you for watching.